Alright, good evening, guys. Today we're going to do differentiation, application of differentiation. I believe that we have done the theoretical part with you. So now we are going for application. Yeah. The first application we're going to do is the rate of change. Alright, before we start with the rate of change, there are some formula I need to write here. I suppose you guys know this. Profit equals to revenue minus cost, and then revenue is equal to quantity multiply price. Okay, these two formula, two equation we will use throughout our exercise here. Okay, let us look at example 1 here. Okay, suppose that the revenue function for a product is given by this revenue function, where x is the number of units sold. Find the marginal revenue function, and the value supposed to be, there's some typo here, and the value of marginal revenue function when x equal to 15. Okay, so example 1, first thing is rate of change. For us to find the marginal revenue function, it is simply you have to differentiate that. Okay, if the question asks you to find marginal of something, you differentiate. So this is the function here. So when they ask for marginal revenue, take the revenue function, you differentiate. If you differentiate this, you will have a 10 here, plus use quotient rule. Okay, quotient rule, remember this one, quotient rule, UV. So in that case, if you use quotient rule, you differentiate U, you will get 100, copy V, minus differentiate V, you get 3, copy U, divide by V square. And if you simplify this, you will end up here. You will end up here. This is marginal revenue function. Okay, so you differentiate, you will get marginal revenue function when x equal to 15. What is the marginal revenue function? You will get 10.2. Okay, that is the question, and that is the answer. Okay, for the question they ask, this is the marginal revenue function, this one. And another one is when x equal to 15, what is the marginal revenue? That is 10.2. What this 10.2 actually is? Okay, what this value is? Okay, this value is, let me tell you clearly. We know the revenue function is this one. So when x equal to 15, you find what is revenue. Okay, what is the revenue for 15 unit? Maybe 15 x, let's say x is shoe. If you sell 15 shoe, how much revenue, okay, you are getting? You are getting, you press in the calculator, you get $180, 180 ringgit. Okay. Now you go for x equal to 16 now. If you sell 16 shoe, how much you get? I'm just giving an example where x is a shoe. Don't find where is the shoe here. Just example. You can consider x and any things, any units. I'm just giving an example. This one is 190.19. Now if you minus, you will get 190.19 minus 180, and you will get 10.19. This is almost near to 10.2, the one we found just now. So this marginal revenue basically is, let's say they're asking marginal revenue value. Okay, marginal revenue value at x equal to 15. What is 10.2 is the difference. Okay, how much it is increase or decrease after 15 units. We are talking about revenue. The increment in revenue after 15 units. How much? 10.19. But if you round off, you get 10.2. That is the thing. Okay, that is what this marginal revenue is. So basically, if I want to write here the like a formula, if I want to write here like a formula, then how I can write? Marginal revenue of 15 is approximately same with 16 minus the increment 15. Or in other words, if I rearrange this one, this is revenue of 16 basically is, I just rearrange this one, I bring it here, become this one. So either one you can remember. Okay, I prefer to remember this one. This is the main thing, and from here we can remember this one. If I want to write this in terms of word explanation, okay, at a production level of 15 units, the revenue is increasing at a production level of 15 unit, the revenue is increasing at a rate of per unit. So after 15, okay, after you sell 15, how much for you to sell another unit after 15, how much it is increased the revenue? 10.2. Okay, remember, the general formula for this, okay, the general formula, if I want to find the marginal value after x unit, that one should be minus x plus 1 minus x. This should be immediate one. Okay, at a production level of say 15 unit, the revenue is increasing at a 10.2. Okay, that's the interpretation you have to give. In other words, if they ask what is the revenue of 16 unit, you can use this formula here, this one. Revenue of 15 plus, the marginal revenue of 15 plus the revenue of 15. Marginal revenue of 15 is 10.2 plus revenue of 15 is, just now was 180. You can get easily 190.2. Like this. You can also compute the revenue of 16. If you want to find revenue of 16, this one must be 15. If you want to find revenue of 17, then this one must be 60. Okay, we cannot use 15. It won't be accurate. That's what I'm trying to tell you. Okay, so it must be an immediate one. Okay, so if I want to recall back what I teach here now, until here we have profit equation, revenue equation. So first application of differentiation is rate of change. Okay, the question asks you to find marginal revenue function. So if they ask for marginal revenue function, okay, marginal revenue function, marginal means you have to differentiate. Which one you differentiate depends. If they ask for revenue function, find the revenue function and differentiate. If they ask for profit function, find the profit function, you differentiate. Cost function, you differentiate. Okay, depends on the function. Here revenue function, you differentiate. Okay, this is the revenue function here, this one. And they want the value x equal to 15. You replace there, you get 10.2. What is this 10.2? Is actually the difference between 16 and 15. Or in other words, the increment in revenue after 15 units. That is the 10.2 here. Then the rest I give you some formula and I've written here in the written form. And finally I said, if you want to find 16, you have to use 15 here. If you want to find revenue of 17, you have to use 16 here. So the immediate one, you cannot use the 15. 15 is not the immediate one. Okay. Example 2. The company's total sale. This is sale. Find and interpret S25 and S prime 25. There's a typo here. This is not equal. This is plus. Hold on. there's a typo. This is plus here, so if you replace 25 here, you get 7 here. So the interpretation, they ask you to interpret, isn't it? This one is the company's total sale after 25 month is $7 million. That is the interpretation. Okay. Now for S, if you want to find the the first derivative, or you want to differentiate S, okay, just now was this one square root, I can write it as power 1 over 2. We differentiate this, you get this, and you can bring this down, and you can write it as like this to simplify. Now if you replace $25 0.1, as I told you, what is the previous, according to the previous exercise we did, what is this 0.1 is the increment in the sale is the increment in the sale after 25 units. Okay, so we're going to write here the interpretation goes like this. After 25 months, the total sales is increasing at the rate of 0.1 million dollar per month. Okay, per month means at the immediate month, okay, in 26. Use this result to estimate the total sale after 26th month and after 27th month. Okay, they ask you to estimate only. They ask you to estimate. Supposed to be like this, like if S26, then as I told you, we have to write S prime 25 plus 25. Okay, s prime 25, we know that is 0 0.1, s 25 is 7, and you get approximate value for s 26 is 7.1. But then if they ask you to find, okay, according to the question, they want you to estimate 27 after 27 months based on the one we have found here, then because we only found s prime 25 and not s prime 25. For s prime 25 is the increment of 1 month. Okay, an increment of 1 month, which means after 25 it increase 0 0.1 in the 26th month. And then for us to get 27th month, it increase some more 0 0.1. So we have to write here 0 0.2 from, if I want to use based on this one, okay, based on this s prime 25, 0 0.1 is 0 0.2. But actually this is not accurate, but if the question asks you like this, estimate only, then we can do. The answer is this one. But then, yeah, this is the answer, okay, you can leave the answer like this, but just to make sure you understand, what is the accurate estimation? I mean, much accurate estimation for S27, you supposed to find X26, S prime 26 plus S26, then only you will get, this is the supposed method for us to find, but since they ask you to use the previous result, we are using this one. Okay, supposed to be, if the question asks you to find this one only, then you have to find this one and this one. Okay, now I leave it as a homework, you can try. If you find S prime 26, you will get 0 0.098. This one is S26 is 7.1, and if you plus here, you will get 7.198. see, you can see this is the actual accurate, I mean estimation. This is this estimation is based on the 25 here. Okay, suppose this one should be the one. Okay, we just, because we follow the question, in case the question asks like this, then you use this one. It all depends on the question, what they're going to ask. Number 3, exercise 3, or example 3. Suppose the daily cost in ringgit for a certain factory to produce X kitchen blenders. Okay, find the marginal cost. Marginal cost. Marginal means you have to differentiate. What you have to differentiate? Cost function. Cost function is given here. So let us differentiate this. I'm straight away going to differentiate, and I don't want to write again. So if I differentiate this, I get this is the differentiation, and when you put 80 inside here, you get 3.2. So what is this 3.2? After 80 units, the cost increase by 3.2. So if I want to write this, at production level of 80 blenders, the total cost is increasing at per unit. At a production level of 80 blenders, the total cost is increasing at rate 3 ringgit 20 cent per unit. That's the interpretation. Example form. Company manufactures automatic transmission for cars. The total weekly cost of producing X transmission. Okay, find the marginal cost. Okay, marginal means you have to differentiate. If you differentiate this, you will get 600 minus, that is answer for A. Find the marginal at production level of 200. So replace 200 here. Interpret the result in part B. At a production level of 200, at a production level of 200 automatic transmission, the weekly cost is increasing at the rate of $300 per unit. Okay, that is find the exact cost of producing the 21st transmission. They are asking exact cost. If they ask for exact cost for the 21st transmission, take total cost of 201 minus total cost of 200. I leave it this as a homework. So if you compute total cost of 201, you will get 140299 minus this one is, you will get 299.25. This is the exact value. Okay, that's regarding rate of change. Okay, now we are going for next application, which is maximum problem. An office supply company sells X heavy duty paper shredder. The price equation, okay, price demand equation is given there. That is the function for price actually in terms of X. What price should the company charge for the shredder to maximize the revenue? So which one we are going to maximize? Revenue. Find the revenue function here. Find the revenue. If they ask you to find, you have to understand. First of all, you need to identify which one they ask you to maximize. Is it revenue, cost, or profit? Identify that. Here they ask you to maximize revenue. So what is revenue function? We need to find what is revenue function. Previously we have seen revenue is equal to price times demand. Okay, so revenue, I read it like this: Rx, price is given there 300 minus x over 30, demand is just x. So our price our revenue function would be 300 x minus x square 30. This is the revenue function. So we found the revenue function. Now we're going to find which for the question is what price should the company charge for the shredder to be maximized, but the price is depends on the quantity x, isn't it? So we need to find x first. Okay, we need to find x first. Since we are based on revenue function, find x which maximize revenue. We're going to find x which maximize revenue. The first method is you differentiate. For you to find x which x maximize the revenue, you differentiate the revenue function. And then make equal to 0. And if you solve this, your x will be 4500. So we found the x. Okay, we found the x. Now we have to double check whether this x gives you maximum revenue or not. So for us to double check, we do a test called as second derivative test. Okay, don't worry, second derivative test is very easy. Just now you differentiate this. When you differentiate this, what you get? 300 minus x over 15. Now second derivative test, you differentiate this again. You differentiate this again, you will get only negative 1 over 15. The idea goes like this: if the second, let's say the function in generally I put f here, let's say second derivative test is less than 0. Okay, if a second derivative test, you find second derivative test and you find out that it is less than 0, then it is a maximum. Okay, the x gives you a maximum value. If you find out that your second derivative is greater than 0, then the x gives you minimum. That's the rule. Now look at this one. Is it greater than 0 or less than 0? This is less than 0. Therefore, it gives you maximum. The x equal to 4,500 gives you a maximum revenue. Okay, this is the test we confirm. Okay, to confirm that x gives you maximum revenue, we have to do this test here. Once we confirm this, we take this one. Okay, we take this value to answer all this question now. Okay, now our x is, we have proven that, okay, we have test or we have confirmed that x 4,500 gives you maximum revenue. Now let us answer the question. What price should the company, what is the formula for price? P equal to 300 minus, okay, for the x you replace 4,500, so you will get 150. This is the answer for P, the price. So in other words, the price is dollar, so we can write 150. Okay. And what is the maximum revenue? Just now the revenue function was 300. Replace the x, 4,500 minus if you do this, you will get. So you can notice that for us to find the price and revenue, we need the x. We need to find the x. How to find the x? I go back again. How to find the x? See which one they want to maximize. Is it revenue, cost, or profit? In this case, revenue. Find the revenue function first. Find the first derivative. Equate the derivative with 0 and find the x. Okay, once find the x, the fifth one is you test whether this x gives you maximum revenue. Okay, this is the rule. If it is less than 0, it is maximum. If it is greater than 0, it's minimum. And then the rest, you just answer the question. For number example 2 now. Or before example 2, maybe I can write the interpretation here. The company will realize a maximum revenue of when the price of a shredder is 150. That is the explanation. Now example 2. The annual cost of manufacturing X paper shredder for the office supply company in example 1 is, so this is the cost now, just now was revenue, this is cost. Just now they give you price demand function and ask you to find revenue. This one is a cost, or what is the company's maximum profit. You see this one now is maximum, they want profit. What is the formula for profit? Profit is revenue minus cost. Okay, just now our revenue was 300x minus x square 30. This is the revenue, the previous revenue, this one, this one, we find the revenue already, minus the cost. You can minus here, I don't have enough space, that's why I do it down here. If you simplify this, you will get 270x minus x square 30 minus 90,000. That is the first one we have to find, the profit. Okay, profit. What they want, what is the company's maximum profit? For that we need to find the x value. How to find the x value? We differentiate this, and we differentiate, we get 270 minus x 15. After that, this is the first. What is the second? Second is differentiate, isn't it? Differentiate is second. The third one is we equate with 0. Third one we equate with 0 for us to find the x. This is the third one. If you solve this, your x will be 4050. That is the fourth one. That is the fourth one. This is the third one. Now, does this x really give you maximum profit? What you have to do? Second derivative test. Number 5. Take the first derivative, this is less than 0. Less than 0 always gives you maximum. Okay, proven. That x will give you maximum profit. Now what is the company's maximum profit? Maximum profit you replace inside the function just now, when x equal to 40. They are asking what is the company's maximum profit, you replace inside here, equals to 270 and if you compute this, profit would be, is this in dollar? Yeah, it's in dollar. This is the profit. What should it charge for each shredder and how many shredder should be produced? Okay. Uh, how many shredder should be produced? That is x equal to 4050. How much it is charged? Just now we have a price formula here. You will get 165. Okay, the quantity, how much? The quantity is 4050. We already find that. Okay, so if I want to write this in Word, you can write this in your own word. Let's say, make sure all the information are there. The maximum profit of blah 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 is realized when 4,500 shredders are manufactured annually and sold for 100. This is dollar 165. This one let us put in dollar because just now in the question is dollar. For sold for 165 each. Okay, that's the explanation. You can give your own explanation, no problem. Okay, and the last one, example 3. The company manufactures and sells X smartphone per week. The weekly demand price and cost respectively, all these things. Okay, now what price should the company charge for the phone and how many phone maximize the weekly revenue? So this is revenue function. What is revenue? Price. What is price here? Times demand. So if you do this, Rx equal to 500x. I suppose before you see this third example, you try yourself first and then you compare the answer with me. As usual, we want to answer any question, we need to find what is the x there. As you can see the previous example, we find the x first, then only we answer the price or the revenue or profit, something, cost, something like that. Find the x first. So this is the first step. Okay, this is the first step. Second step, you differentiate. This is second step. Third step, you equate with 0. So you find the x now. This is the fourth step. But is this x gives you a maximum, what you have to do, second derivative test. That is the fifth one. So second derivative test, take the r prime and you differentiate again, get negative 1, which is less than 1, less than 0. Less than 0 gives you maximum revenue. Okay, we have proven that x here gives you, this x here gives you maximum revenue. So we can start answer any other questions now. What price should the company charge for the phone? So when x equal to 500, price this one would be 250. Okay, the price here I didn't put anything, I just put all of us, or we can put RM because I didn't put anything. Then what they want, and how many phones, we know this one, this is the how many phones, this is 500 phones, 5 quantity, how many phones, 500 phones. What is the maximum weekly revenue now? Maximum revenue. Maximum revenue is this is the answer. Now B. Now they want maximum profit now. So maximum profit. Oh, before that, let me write the interpretation here. This is the explanation. Now for B, weekly profit. So we need to find the profit function. Profit function is revenue minus cost. Revenue was just now profit function is this one. First step. Second step is you differentiate. Second step. Third step is equate with 0. Third step. You find the quantity already. Okay, this is the fourth step. And what you have to do now, the fifth step, to prove that this quantity gives you the maximum profit. So second, derivative test. Second derivative test. You get negative. This is maximum. So we have proven that x equal to 365 is giving a maximum profit. Now let us answer the question. When x equal to 365, how much should the company charge for the phone price? P equal to 500 minus 0.5365, you get 3 price. Just now I put RM 317.5. And then what they want, how much, how many phones, quantity, three, 6, 5 phones. And the last one is maximum profit. Just now profit function was 365x. This is the answer, and you can write the wording now. this is the complete answer. Okay, this is the application of differentiation. Now you can do your tutorial. I will send you the complete answer for all the tutorial, the working, complete working. Of course, in the tutorial, you can see the answer only at the back side, but I will send you the complete working for all the question for differentiation. Okay, you can refer, and before you refer my answer, you try first and then you refer to the answer, check the answer. Alright, with that, that's all for differentiation. I'll see you guys in our next class then. Take care.